Today we're talking about graphing proportional relationships. When two quantities are proportionate, they have a constant ratio or rate. This is called the constant of proportionality. We also consider this our slope. So in this particular situation, the total cost in dollars and the number of wristbands are proportional. Because if you pay $6, you're going to get 4 wristbands. If you pay $9, you'll get 6. If you pay $12, you'll get 8, which all equals $3 for 2. This is the simplified slope or constant of proportionality. If we look over here, $6 for 4 necklaces, $10 for 5, and $15 for 6 necklaces are not proportionate. So sometimes things are non-proportional. So we need to make sure that we can find the constant of proportionality and know that that's our slope. So in this example, they want us to determine whether the cost of the coffee is proportionate to the number of pounds. So if the relationship is proportional, they want us to identify the constant of proportionality. So the way we do this is we look at the unit rates. So we look at how much it costs for each pound of coffee. Here it's $3 for 1, here it's $6 for 2, $9 for 3, and $12 for 4. If we simplify all these, all the rates are equal, which means the constant of proportionality is 3. What if we wanted to then look at a table or a graph? This can be graphed as our slope. So if we look at the coffee in this particular table and we plot the points, we know at 1 it's going to be 3, at 2, 6, at 3, 9, and at 4, 12. If we look here, it's rising and running at a constant rate. It's passing through the origin. This is important because that's the only way that you can determine that something is proportional on a graph, is if it passes through the origin. If this line would have moved up, for instance, I can't move it. If this line would have moved up here, for instance, it's not passing through the origin, so it's not proportional. Okay, so determine whether each relationship is proportional by graphing on the coordinate plane. If we graph these, and we look here, all of the factors lie. It passes through 0, 0, and all of the ratios are constant. Each one of them are proportionate to each other. So they all rise 5 and run 1. So this is a proportional relationship. So let's look at this one. A candle is 20 centimeters tall. It burns at a rate of 2 centimeters per hour. Is the candle's height proportionate to the number of hours that it burns? Go ahead and think about this one. Make a table and make a graph, and I'll be back in just a second to show you what I did. Okay, so the first step is to make a table. So we're going to make our table consisting of, at 0 it's 20 meters tall, then it burns at a rate of 2 centimeters per hour. So every hour it's decreasing 2 centimeters. So if we look at these, do they have a constant rate of proportionality? And the answer is no. If we try to graph each one of these, it's not passing through the origin. And if we look at our unit rates, remember, never use 020 because it'll give you that divide by 0 error. But if you use the other ones, 18 over 1, 16 over 2, 14 over 3, and 12 over 4 do not simplify to equivalence. So this is non-proportional. Let's take a look at these. When practicing, Sam scores 4 goals in 3 minutes. Find the slope or the unit rate and graph this proportional relationship. So they're telling you that it's proportionate. So what you need to do is you need to label your independent and your dependent variables, determine your scale and your title. Let's do that one together. So he's going to score 4 goals in 3 minutes. So if we use the scientific approach, it's the effects of the number of minutes played on the number of goals scored. If you want to go math-wise, you can just say Sam's goals. All right? if we look here, this is going to be our independent variable, and this one is always our dependent variable along the y-axis. So if it's independent, that's our time in minutes. So we want to see that every 3 minutes something is happening. Over here, we have our goals, the number of goals that he scores. So we know he's scoring 4, so let's go up by 2s on this one. If we determine our scale over here, I would say we could go up just by 1s. So start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in 3 minutes he scores 4 goals. In 6 minutes that would mean he would score 8. And in 9 he would score 12. How many does he score at no minutes? 0. So this is proportional. They told us that already. And if we graph it, we would want to make sure that our line goes straight through each one of our points and has an arrow at the end. Make sure that you do that. This is continuous. It has an ending point, but over here we could still, even if we didn't have this graph, extend the line further and further. Go ahead and try this one. Ryan and Jacob baked 24 cookies in 18 minutes. All right, go ahead and graph this proportional relationship. I'll be back in just a second to show you what I did. Okay, so the first thing that I do is I make sure that I have my titles, difficulties. So we have 24 cookies in 18 minutes. So that means if we simplify this, what number goes into both 24 and 18? Well, if we simplify, both can be divided by 6, so we get 4/3. When we look at this, so that means that's 4 cookies every 3 minutes. So I'm going to make my minutes go up by 3, 3, 6, 9, and if you picked a different scale, that's totally okay. Don't even worry about it. Just make sure that you have a constant scale. And then over here I'm going to go up by 2s. So if I plot these points, I'm going to go every 3 minutes 4 cookies. Okay, so as you can see, it's going up at a constant rate, and then I'm going to draw a line through the points. Okay, make sure it has an arrow. Now let's compare. Laura makes 15 friendship bracelets in 2.5 hours. Hayden makes 21 friendship bracelets in 3 hours. Which proportional relationship has the greater rate of change or slope? Let's prove it by graphing. Okay, so let's put our labels on first. Okay, so I went up by 1 hour, and then I made my bracelets go up by 4. If you look here, she can make 15 in 2.5 hours, so she can make 6 in 1 hour, which means she can make 12 in 2 hours. Sorry about that, my scale was a little off. So she can make 3 then in how many hours? Let's think about this. That would be 18, and then she can make 4 in 24 hours. Over here, Hayden can make 7. So she has 7 here. She's going to have 14 at 2 hours. She's going to have 21 at 3 hours. And she would have 28 at 4 hours. Which would be 20, oh, that's going up. Perfect, 28. Okay, so let's make our line here. Who has the greater slope? If we look at this, the 7/1, Hayden has the greater slope. And it's slightly steeper on our graph. Go ahead and try these two for me, and I'll be back in just a second to show you the answers. Okay, so here are my labels. Now let's plot our points. Okay, so I plotted my points, and I look at my unit rates. And if you look here, Caroline is downloading more every minute. And that's all I've got for you today. See you next time.